So one of the questions we'd like to ask you, Simon, is if you were to rerun the tape of life again, rerun evolution again, would something like ourselves grace the replay?
Well, the simple answer is we don't know, because the tape of life has only been run once, inasmuch as, so far as animals are concerned, the story more or less begins in the Cambrian explosion about 500 million years ago, and the conceit of rerunning the tape of life goes back to at least Stephen Jay Gould. He said, look, if any one of them had gone extinct rather than another one, then it's just as likely our ancestor would have gone extinct rather than somebody else, and therefore we would not be there. Therefore, his argument was, rerun the tape of life, there would be animals, but nothing like ourselves. And I think this is wrong.
Okay.
The number of opportunities, if you like, the number of solutions by which biology arranges itself are surprisingly limited. So if we were to rerun the tape of life, my estimation would be that indeed there would be something really pretty similar to a human, in fact something pretty similar to this conversation, but there would also be an entire biosphere. So I'm not restricting the argument merely to intelligent bipeds with skills of manipulation and higher cognition. There would be animals in the sea, there would be plants in the forest, but in each and every case, the sort of end form which we see today from the beginnings of the Cambrian explosion would be surprisingly predictable.
Given what you said about the traditional view, how does your view then take issue with it? How is it different?
Well, in one sense, the views of biology are unified in as much as everybody agrees that to the first approximation, Darwin was right. Evolution happens, evolution is a reality, and all the rest of it. Really, the difference, I think, is those such as most of my colleagues who emphasize the degrees of randomness in evolution, the uncertainties, the unpredictability about it. And at first sight, this seems very reasonable. Mutations are more or less random, perhaps. Correspondingly, mass extinctions are meant to be more or less by chance, and the survivors are the lucky ones. And there's certainly a lot of truth in that. I wouldn't deny it for a moment. But on the other hand, if you stand back slightly, there seem to be recurrent patterns. One has to also point out that not only is there recurrence in biology, this is what we call evolutionary convergence, but there's also evidence that in a broad sense things are becoming more interesting, almost more complex. So there are, if you like, trends towards greater complexity, but beneath that there's a sort of drumbeat which more or less says, how many ways can you do something? How many ways can you fly? How many ways can you swim? How many ways can you breathe? How many ways can you think? And it then turns out that if you look at evolutionary convergence, there might be a rather limited number.
So, I mean, is convergence then, if you were to try and give it a definition, is it natural selection finding the best solution to a physical problem or an engineering problem, or?
Effectively, yes. I mean, the point about convergence is that one can show by mathematical modelling that it can, in principle, happen by chance. After all, evolution has to go somewhere. And you can also make the observation, in fact, if you've got a certain, what we call a body plan, then there are constraints on what you can possibly do. Most people argue that it, in a sense, reinforces our idea of Darwinian adaptation. Some things work, other things don't. I think the crucial difference is two things. First of all, convergence is ubiquitous. I can't think of anything which has only evolved once, or very, very few exceptions. And the corresponding point is that if you look at the total number of alternatives which biology in principle could throw up, as Ard will know as a mathematical physicist, the numbers are stupendously, stupidly big. Far, far more than the number of particles in the visible universe. And yet out of this immensity of possibilities, at least on this planet, the total number of solutions is a handful.
That's essentially what caught your attention, is answering that. How come out of all those possibilities it's just these few over and over again?
Absolutely right. The degree of similarity and the possibility of alternatives which have never been realised begins to sort of tweak the imagination. It's a sort of what-if experiment.
Yes. So it's random, but because certain solutions are just the solutions that work, then natural selection will randomly find them.
Yeah, there's nothing wrong with randomness. Yeah. The world won't work without it, but the world is also ordered, and it's in a sense a paradox of how do you get this self-order emerging from what is originally, of course, just this sea of early particles, and coalesces not only into planets and galaxies and all those good things, but also life forms which, in a certain sense, begin to step out of physics and chemistry into new worlds.